is equal to 3.1 square root of x plus 19 models the median height f of x in inches of girls who are x months of age. The graph of f is shown here. So here is the height, and in the x-axis the age of the girls in the months. So let's see here what in the other slide of what we have to solve it. Describe how the graph can be obtained using transformation of the square root function f of x is equal to the square root of x. So if we want now to obtain, if we want to see how we can obtain this function, that is f of x, again I'm writing with the same denotation, but let's say this is a blue and the other is with a black color. This one is a 3.1. The function is a square root of x and is plus 19. So this is the function here. And now we want to know how did we obtain this function from this function f of x square root of x. But as we see here, 3.1 is a vertical stretching factor. So is a vertical stretching factor, It means that the function stretches vertically with the factor 3.1. So let me write here with abbreviation. Vertical stretch factor 3.1. So, and the other fact is, so this was 3.1. And the other transformation is a 19, plus 19. It means that the function translates vertically for 19 units up. So this is a vertical translation or vertical shift up for 19 units. Now, according to the model, what is the median height of the girls who are 48 inches months or 4 years old? Use the calculator and round to the nearest tenth of an inch. The actual median height for girls at 48 months is 40.2 inches. So the 48 months, they are with the actual median height are 40.2 inches. How well does the model describe the actual height? So now f of x here, instead of the f of x, this function what we have here, we are plugging 48 months because we want to know how much is the height of the girls who are 48 months. So let's see how this function is going to describe the height. Is going to be closer to this value or not? And whenever I have x, I plug in here 48. And let's see what we get. Plus 19. And now we are in this position. What we are doing here, let me take a calculator and calculate everything here. So in a calculator here, we are plugging 48, but is a square root. So I'm taking square root, and is a time 3.1, and we get this value here. Plus this 19 we are adding, plus 19, and is a 40.477. But if I am approximating to the nearest tenth, I'm going to take a 40.5. So f of 48 months, according to the function, it says is a 40.5 inches. So it's a 40.5 inches tall. So we see here. And if we are comparing with the actual median height of the girls, 40.2, so the error is plus minus 0.3 inches. So it's very, very close. So this I can describe a very close to the height of the girls with respect to the age of the months. So now let's see here. Use the model to find the average rate of change in inches per month between a birth and the 10 months, rounded to the nearest 10. So here is a 10 to the nearest 10. So let me write here a 10, because I forgot to write. So now the average rate AV, let me write AR, the average rate, and the average rate formula we already know is f of b. The difference between 2 points, we find it, f of b minus f of a divided by b over a. Okay, let me write this formula. So when we are going to rely on it. b minus a, b minus a. And now in our case, we have to look, for example, between birth and the 10 months. If we are looking here, birth is a 0 and 10 months is here, and we are seeing this a difference. Because already we know in 0 month they are 19 inches. And now let me plug here in these numbers. Instead of a b, I'm plugging here a 10 minus 0, and f of 10, I'm plugging on the function f of 10 minus f of 0. The function is almost the same function, but whatever I have of the sign here of the function in the other function, every sign is going to be negative, is going to change the pre-sign, because of this minus here is going to distribute it in this function. So that's why here I'm going to look. First of all, I'm going to plug in an f of 10 in the function. Whenever it is x, I'm plugging 10 here, and there's a plus 19. And in the other side, f of 0 is 19. And f of 0, I'm plugging the same thing, but instead of the x, I'm plugging 0. And what I'm doing here, I'm changing the sign, because of this sign here is going to change all the signs in the function, and it's minus 19. And here we can take one shortcut, very easy. Here is a 10 minus 0. 10 minus 0 is 10. But here is plus 19. Minus 19 disappears. But 3.1 times 0 is 0. So what remains just 3.1 times square root of 10 divided by 10. But let me rewrite this again. So I think, because I think it looks better, because otherwise we don't know what we did here. So whatever remains is 3.1 square root of 10, and everything is divided by 10. So here we can calculate everything, and we can see what is the average change per month. But let me take a calculator here first of all. And now what I have here in this situation, let me put here a calculator so I can see it. I have a square root of 10. Let me take a 10 here. I'm going to do the square root. I got a 3.16, and times 3.1. 3.1. We get a 9.8. But this one we divide by 10. We divide by 10, and the final result is a 0.98. But if I am taking an average, this one is going to be 0.100, or is around 1 inch. Is going to be around 1 inch. Or let me write a 0.98. 98, or approximately this is going to be 1.0 inch. So this is approximation. If we are rounded to the nearest tenth, it's going to be 1.0. 1 inch per month. So now in the D, use the model to find average rate of change in inches per month between 50 and 60 months. Round to the nearest tenth. How this compared to your in a part C? How this difference shown with the graph? And now let's find the average rate. Now here they're asking us between 50 and 60 months. So now whatever we have here, I'm going to plug f of 60 minus f of minus f of 50, and this is going to be divided by 60 minus 50. It's very obvious it's going to be 10, but let's write it down. 60 minus 50. So let me calculate here very quickly, because on the lower side here is going to be 10. 60 minus 50 is 10, so I calculate immediately. And here is 3.1 times square root of 60 plus 90 okay, and is a minus 3.1 square root of 50, and this minus 19, minus 19. Again, these two are with the same sign, same quantity, and here I have a 3.1, so the average rate is going to be equal with 3.1 divided by 10. So let me take this as a factor, and inside is going to be square root of 60 minus square root of 50. So this is the difference. Maybe we leave this way, it looks good, but we want to find the exact value in this, in the decimal numbers. This is 50, okay, and we see what is going to be. Let me rewrite again one more time. 3.1 divided by, here is a point, divided by 10. We are almost to the end, and let me write here those in the decimal numbers. So let me take a calculator here, and let's see what we can get. Let's go liter upper. So 60 in the square root of 60 is 7.74. Let's say 7.7. Let me take this 7.7. 7.7, because we are rounded to the nearest tenth, is a minus. Now we are looking for a square root of 50, what we get. And for the square root of 50, square root, we get 7.07. Let me take it, this is a 7.1 if we are rounded to the nearest tenth. Is it 7.1? And now we have everything here. We have a 7.7 minus a 7.1. We get a 0.6, but 0.6 times 3.1. I want to see what is the time 3.1. We get in 1.86, but now this we are dividing by 10, and 0.186. So average rate here is going to be equal with 0.0, let me write it, 0.186 or 0.2 if we are rounding to the nearest. 10 is a 0.2, and here was 1 inch between the birth and a 10 months. So the average rate was very quickly, so we are comparing those two now, but the average rate between 15 months and 60 months was 0.2. So it means from between 10, it was a growth just 2 inches per month, 0.2 inches per month, but here was 1 inch per month during the first 10th month. During the first 10th month, the child or the girl is growing very fast compared to the from 50 to 60 months.